figures. Plastic, rubber, metal like aluminum, ferrous, gold, etc. can be tested. The box size is about 200 by 150 by 100 mm. So the specimen of this size can be checked. UTM. The capacity of this machine is 40 tons. A dumbbell shaped specimen is prepared as per standards. The dumbbell shaped specimen is held between upper and lower jaw of the machine. Sometimes direct piece can also be checked. A selected load is applied such that the selected load is double to the expected failure value of the material. Stress versus strain curve is drawn by the machine software on a graph. The material first passes the inelastic limit, then it goes to the plastic deformation on reading yield point, then occurs necking. When the diameter of job becomes narrow, then the neck breaks. The maximum stress occurs. The peak value to ultimate tensile strain of material. At this point, the material has elongated maximum. Thus, the final length less initial length divided by initial length into 100 is percent elongation. The length is measured between mark point, roughly 50 to 60 mm is the initial length. Some machine can be used for measurement of compressive strength. In this case, the middle jaw and lower jaw squeeze the specimen up to failure. Cupping tester. The machine is used to measure drawability of sheet metal, steel or copper or aluminum. The sheet of size 150 by 100 mm is held between a gap in machine. The thickness of specimen sheet to be below 2 mm for this machine. Higher capacity machine are used for larger thickness. A ball in a bolt ram is pushed by moving the wheel. The wheel has a linear and round vernier scale mounted. On pushing the ram over the sheet specimen at a particular point, the ram ball heads punctures the sheet after pushing the material to same extent. A light reflector is used to see the puncture crack. At this point, measurement is taken on scale and vernier. This is converted to Erickson number using a table. Erickson number indicates drawability. Magnetic particle test. External cracks in ferromagnetic materials like steel or iron casting can be checked. These are surface defects. The job is held between a copper pads on the jaw of table. It is held tight. A current of 1000 to 2000 ampere is passed for a fraction of second. As the result of passage of current, the part gets magnetized. On this, colloidal solution of fluorescent material in oil is spread over the piece. Due to magnetization, the fluorescent powder will stick the cracked cap. On seeing through ultraviolet light bulb, this fluorescent material will spark. The presence of fluorescence will indicate the line of crack. Afterward, all these pieces are demagnetized and used. The crack will be marked suitable ink, pen, paint. Ultrasonic testers. As the name suggested, a very high frequency megahertz sound wave is used for testing internal defects material specification. The specification should allow the passage of sound wave. The machine has a megahertz sound generator which sends sound waves through the lab specimen. At entry paint it, the graph will show a peak, and at exit point the graph will show a peak. The entry and exit paint are edge of the specimen. If there is any flow in between, there will be intermediate peak on the graph. This shows the location of the defect on a linear scale. We can thus make measurement on XYZ axis and find the exact location to the accuracy of plus minus 5 mm. A test piece up to 6000 mm length can be checked. A quartz probe is attached to the machine. The graph vibrates as results of ultrasonic waves. Oil is applied as media on the test piece for passage of sound waves. A graph is seen on a monitor. The data can be stored. Decibel value of wave is selected based on the size of the specimen to be checked. The internal defects such as porosity, inclusion, internal cracks, fold, lap, blowholes can be detected on this machine. Torque range tester. We have torque range tester having range 2000 Newton meter, least count of 0.1 Newton meter with accuracy of 1% of reading. We can calibrate adjustable type, dial type and digital type torque wrenches on this tester. As per IS standard, first we have to take reading at 20%, then 60% and finally at 100% of range. After mounting torque wrench on tester, torque is generated by rotating a wheel, and at certain stage torque wrench clicks and the peak point value is noted by DRO. Tape and scale calibration unit. On this unit we can calibrate measuring scale as well as measuring tapes. Range of this unit is 1000 mm and least count 5 micron. With the help of DRO and camera we can measure graduations on scale or tape with magnifications. In case of tape, readings are taken in the steps of 1000 mm. Gauge block calibration. This is gauge block calibrator. Range is 100 mm and least count 0.01 micron. We have a set of gauge blocks of K grade which is calibrated from NPL. We use this set as a master and calibrating gauge block sets of 0 grade and onward. First the master gauge block is placed in back side socket. Then gauge block to be calibrated is placed in front side socket. Reference value of master, that is deviation observed during calibration, is set on DRO and then the reading on gauge block to be calibrated is taken. Dial calibration. This instrument is used for calibrating plunger dials, lever dials and bore gauges. Least count of this instrument is 0.1 micron and range is 25 mm. Now we are calibrating plunger dial having least count 1 micron. First we set the dial at 0 and then DRO reading also set to 0. Then rotate the spindle of DCT slowly to get desired reading on dial and note the corresponding reading observed on DRO of DCT. By this way we have to take further readings at several points of dial as recommended by standard. Single axis measuring machine. We are using this machine for calibration of inside diameters, outside diameters, length masters, micrometer setting standards, thread plug gauge and thread ring gauges. Range of this instrument is 500 mm with a least count of 0.01 micron. For thread ring gauge we use T-shaped ball probes and for thread plug gauge we use thread measuring wires.
इस रिमूवेबल पिन को आप डालेंगे एंड उसके बाद में आप यहाँ पर इस स्लॉट को चेक करने के लिए स्लाइडर ब्लॉक है, वो स्लाइडर ब्लॉक को आप आगे लेके जाएंगे. स्लाइडर ब्लॉक अगर अंदर जाता है तो योर जॉब इज ओके. नाउ व्हाट शुड बी द साइज ऑफ स्लाइडर ब्लॉक? स्लाइडर ब्लॉक साइज शुड बी इसका मैक्सिमम मेटेरियल कंडीशन. व्हाट इज मैक्सिमम मेटेरियल कंडीशन? 10.2. उसमें से This positional tolerance minus. So 10.2 minus 0.2 is the 10 mm. So slider width will be 10 mm. So this is how this gauge need to be designed. You are checking this slot by two things. You have a bone over slip gauge also.
Right.
तो सबसे पहले आप स्लिप गेज से चेक करेंगे, फिर आप फंक्शनल गेज पे आओगे, तो वहाँ पे वो डिस्क्वालीफाई हो जाएगा स्लॉट वेट। ये दोनों के पर्पस अलग है। आपका इंडिविजुअल गेजिंग ये बोलता है कि वो फीचर ओके है कि नहीं वो देखना, एंड फंक्शनल गेज स्टॉक्स की ये जब फंक्शन में जाएगा, जो पर्पस के लिए ये प्रोडक्ट बना है उसमें जाएगा, तो वेदर इट विल फंक्शन और इट विल फिट और सो फंक्शनल गेज गिव्स यू फिटमेंट, डायमेंशनल गेज टेल्स यू वेदर दैट फीचर इज राइट और नॉट। सो जब ये जॉब डालोगे आप तो ऐसा दिखेगा।
I am happy to note that we could complete 8 batches of Metrology Dexterity program, which covered 80 participants from various Mahindra plants. Here are some of the feedback from participants.
Many concepts I have learned earlier also, but some basics. So these 2 sessions are very helpful for me.
Good evening everybody. The 2 new things that I came to know was GD&T. I only knew the full form like I said earlier, but really it is a great topic and it eases out a lot of things from drawing to production. So definitely it will be applied wherever, to whichever supplier we are going. And second was the calibration. We always knew what calibration is, but now seeing it, doing it, like yesterday I said again, when we get the master in our hand, we think it is the Bible. But now we have so much of empowerment that we can question that also and get the results right. And the supplier has stopped its supplies because of some financial issue, and the process has been outsourced. So we were trying to validate the part which is coming from a different source. So the part is a pipe and a bracket is welded. So when I went to the inspector for getting the dimensional checking for doing the PIST, so there in the drawing it is given the bracket length from this side to the center of the circle, and the inspector said, I wonder how I will do this. That was the first question he asked. Then I said, you are a better man than I suggesting you. Then he took around half an hour taking multiple calculations and then deriving to a, because like Suhas sir rightly said, it is the center was imaginary. So he had to take so many measurements, and to his caliber he calculated the center distance and came out with his mathematical formula. So but GD&T's application, if it is feature wise given, then will definitely help in all the aspects.
So our session was very gainful, and we learned about the basics of calibrations and measurements.
We gone through a different new technology equipments which we haven't heard or seen. So calibration, the mechanical lab was really good. So first of all, earlier we used to go, if the instrument is calibrated, we used to stop there itself. Like we used to see the due date and we used to say it is okay or not okay. But now we can challenge how it is okay, what is CMC, so what is the capacity of the lab which has been certifying this instrument, is it okay or not okay. And we came through this vacuumized combustion chamber, really very good. Actually this was a very good opportunity to come across this advanced and latest equipments under one roof. And I would recommend all this program to all new joiners. It will be very informative. And finally, I would only say one thing, that is, as yesterday I told, if you can measure it, you can definitely improve it. So this program gives us strength to measure something. So if you measure, then it will be improved automatically.
And we got to know about all the new equipments today, and we got to know about hazardous material, ROHS.
Yesterday's session was very basic. I have been through this, but not totally. I was having a little bit of information about micrometers, screw gauges and all, but not much. So yesterday I did learn a lot about this basic instruments which I used in day-to-day life. But today it was much more advanced. I just learned how to that torque wrench. It was unknown to me how do they calibrate this.
We have learned a lot of new things, just like Magna Flux. It is a crack detection machine is there. Then so many times we are coming across only the reports, just like as a chemical composition report is there. Then calibration report of the plug gauges, vernier calipers. But exactly what is going behind that? Today we come to know about those things. Exactly how they are calibrating, how exactly the process is going behind the calibration process. Just for example, we are using ACTA in our regular process. ACTA is same thing for the torque wrench calibration. One of the same thing. So we are just taking it as just a measuring instrument. But by comparing this session, it is I'm just saying that it is a calibration of my torque wrench.
The training session was arranged brilliantly.